So good afternoon, Spanker here again, episode 3 Arduino. So what are we going to be doing? We're going to quickly look at some of the pre-programmed sketches. So we did the blink one last time, which just blinked an LED. So if we quickly look at what other sketches we've got, so if we go into examples, basics. So there's 5 or 6 here. So what we're going to look at first is we're going to look at this fade one. So I'll pull that fade up. So what this is saying in the comments here, as you see it's commented out, is example shows how to fade an LED on pin 9 using the analog write function. So if we it says the analog write uses PWM, so if you want to change the pin you're using, be sure to use another PWM capable pin. Most Arduinos, the PWM pins are identified with a little tilde sign, 3, 5, 6, 9, and you won't be able to see it on camera, but looking at this, 3, 5, 6, 9, 10, 11 have the little mark on the board. So let's just pull that up. I don't know if you'll be able to see clearly. You can't see, the autofocus on the camera's a bit crappy, but they are there. So what we're going to do is we'll build the circuit first. So we want an LED, positive leg in. I'm going to put a resistor in, so a resistor onto the positive leg and onto there. Then what we're going to do is from the resistor, that's going to go to pin 9, and from the negative leg of the LED will go to ground. So first, before we plug all this in, let's just upload this sketch. So quickly, I'll just hit the upload on the sketch. That's uploaded. So now if I plug in pin 9 and then a ground, so we can see there. Can we see there? It's hard to see on this camera, but the LED is going from low to high, back to low. It's slowly going up. I can just about see it on that. It goes up and down. Very hard to see, but believe me, it is doing it. So let's look at what this sketch does. So first of all, the first function that's bringing up here, it's saying int LED equals 9. Now what int is, it's just declaring an integer. It's declaring a number, and it's an all number. So it's saying that every time you see LED in the code anywhere, it's really number 9. And there's a few reasons for that. There's a few reasons that we declare a word instead of a number, even though a number is shorter. First reason is that if we had this code looking full of numbers instead of words, we wouldn't know. It'd be very hard to see what number is doing what. It'd be very hard to remember what number's doing what when you're looking through the code later on. So we give them a word, so we know that LED is the LED pin. So later on in the code here, we've got LED. That's just referring to the number 9. The second reason is that we can change these integers throughout the code. So for instance here, this line here is saying change the brightness for the next time through the loop. And what it's saying is brightness equals brightness plus the fade amount. If we add a number in there, 9 equals 9 plus 5, everywhere there'll be a 9 and 5 in the code, which could be relevant to a completely different function, it'd change it, and you might not want it to change. So as we go through the code, I'll explain what these are. But the first thing, after we've got the LED, pin 9, so it's telling us that LED equals 9. That's the pin number that we want. So it's saying the PWM pin the LED is attached to. Integer, create an integer to refer to the brightness, which is 0. So the brightness of the LED is 0. And then the fade amount is equal to 5. So it's declaring that fade amount equals number 5, how many points to fade the LED by. It goes from 0 to 256, the brightness. So we can have 0 is off, 25, well it goes to 255, it's 256 different points. And 0 to 255, 255 will be as bright as it can possibly go. So that just declares what these variables are, or these integers are, which refer back to these words. We then go into the main routine. So the main routine is obviously void setup, which is the startup. The comment here is declare pin 9 to be an output. So we're saying here this function pin mode is declaring what we want each individual pin to do. So it says pin mode, we want pin LED to be an output. And the syntax is important. You've got to have the bracket, a comma, a space for the output, and a colon to end it. But what it's saying is LED to be an output. What is good about this is I could change that pin to pin 6 just by changing that, and everywhere through the program it will refer to it as 6. So initially all it's saying is I want pin 9 to be an output. Done. It's the only output that we're picking up, that it's addressing. Next thing is the loop. So again, as usual, it runs over and over again forever. And the first one, this syntax is important. You've got to start the loop. Set the brightness of the pin, or of pin 9. So analog write is the function. So what analog write does is it says which the standard is whichever number we put in is the pin, write to that pin this number. So what it does is it analog write, it looks for the pin number, which is LED, which is going to be 9, and it sets that write to 0 because brightness is equal to 0. So it doesn't do anything on the first run of the loop, sets it to 0. But it's setting an output, it's actually setting an output to that pin. It's writing a number to that pin. This next line of code here is change the brightness for the next time through the loop. So because this loop runs and runs and runs, it's saying that next time we want to change this variable of brightness from 0. We want to change it up. So it's saying brightness equals brightness, which is itself, plus the fade amount. So the fade amount is 5. So on the first run of the loop it says 0 equals 0 plus 5. So at this point, this very point here, what's happened is it's sent out 0 to the pin, so nothing's happened. It's then changed that variable of brightness to 5 because it's added the fade amount. It's added the fade amount, so now brightness within this loop equals 5. For the point here, we'll ignore that pointer code for now because what's going to happen next, we'll just ignore that for now. It's then going to wait 30 milliseconds and then it's going to start again, and it's going to say write the pin LED, which is pin 9, brightness, but brightness has been changed at this time because of this algorithm here. It's changed to 5, so it'll output 5 to pin 9, which is 30 milliseconds after it's set that, it's wrote 5 to it, which makes it a little bit very dim. Ignore this bit of code again, we'll come to that in a sec. Brightness is 5 equals 5 plus 5. So now at this point in the code, brightness is 10. Brightness is 10. When it gets back, it's going to output 10 to that. So it's gradually going to get brighter and brighter on every iteration of this loop. So it's going to get brighter and brighter and brighter until it gets to 255, because that's the maximum it can output. And this is where these two lines of code come in. And basically what it's saying, it's an if statement. It's saying if brightness is less or equal to 0, or if brightness is greater or equal to 255, then change the fade amount integer to a negative. So, for instance, say we've gone through a lot of iterations of this loop and brightness is now at 255, it's a maximum output, the LED is burning brightly. The next, when it runs this code and says, whoa, just a minute, your brightness is at 255, I've got to change fade amount to minus fade amount. So it changes that number to a negative. So what it then does in the code, when it gets to brightness equals brightness plus fade amount, it's getting 255 plus a negative 5, so it drops it to 250. I think this will probably go to 260 because it gets to 255 and then it runs that. No, it won't go above 255. It should never go above 255. So 25 minus 5, and it drops back down. It drops it back down 5 every time because fade amount becomes a negative number. And when it eventually gets to 0, so that'll be brightness equals brightness plus fade amount, that'll eventually be the brightness is 5 minus 5 is 0. It triggers this to reverse that fade amount back to a positive, negative to positive, and it goes back up. So that loop, all it's doing, it's starting the brightness of the LED at 0, bumping it right up to 255 and then bringing it back down to 0. And it does that in 5 milliseconds, in iterations of 5 every 30 milliseconds. And very simple code, but we look at it's just going right up and down. You can probably see it there at a better angle. I don't know if there's any. It's not very bright. So there's a few things we can do with this. Let's have a look at back to the code. What if I wanted to make it go up and down faster? So I wanted to go from 0 to 255 faster. A few things I can do. I can decrease the delay. I could change that to 10 milliseconds. Upload that code. That's uploaded now, and when we bump it back on, it's actually going a little bit faster. So it's going 3 times faster because we've told it to do it at 10 milliseconds. If I want to make it go slower, I could change it to 100 milliseconds. Upload that code. And now it's going up a lot slower. So I can make it glow. And looking at the LED in the reel with my eyes, I can see it getting to the top, it's coming back down. But it just goes off for a very brief, well, it goes off for 100 milliseconds exactly. When it gets to 0 and this fade amount reverses to send it back up. But if I bring that back down to 30, let's bring it back, I'll bring it back down to 30 milliseconds there. What happens if I change the fade amount? What if I change the fade amount to 150? We'll upload that code. What do we think is going to happen when it changes to 150? So when we're looking at the code, I've changed the fade amount to 150. Delay is 30 milliseconds. And we've got it flashing, flickering, really. Because it's going up to the maximum in 2 steps now. The steps have been delayed quite a lot. Let's change that delay. We'll change that delay to 1000 milliseconds. So 1 second. So upload that sketch. So what we have now is it comes on, dims, bright, off. Because 150 milliseconds isn't a multiple of 255. So it comes off, on, bright, dimmer, bright, off. That's because it's bouncing between the negative numbers of it goes above. It'll go start off at 0, it'll go 150, 300, back to 150, back to 0. So it's flickering above the maximum it can put out. It's very strange that. Should it be doing that? 0. Right, so I'm just wondering, because this is going 0, 150, 300, 150 off. But 300 is dimmer than 250, than 150. So why is that? Why is that? .300 is dimmer than 250. So I'm wondering if 300 is equivalent to 45. Because once it gets to 255, it can't put it any higher. So I wonder if it cycles over to do 256 is equal to 0 again. I think that's what it must be doing. So if we put an output on one of the digital pins of 300, we need to minus 255 from that. I need to check that because I have never come across that before in anything I've done. So I'm thinking that's what it's going to be, because it's going 0, 150, 300 is less, 150 is back to that and off again. So it's it must carry over. So that's that one. What we're going to do now, because we are in for 19 minutes, we've got another couple of minutes before I'm going to get on that. We're going to look at another one. We're going to look at analog read serial. So what I'm going to do is pull that sketch up. Analog read serial. So it's in the examples basics analog read. So what this is doing is going to read. I'll just skin out these while I'm talking. An analog input on pin 0 and prints the result to the serial monitor. So this is what a lot of this is how we're going to integrate what the Arduino is doing to what we see on the screen, because at the moment we have done nothing which is feeding back to the computer. This is going to feed us back to the computer. So what I need to do is just set up a little circuit over on here. So I'm going to set up, I'm going to need, I'm throwing everything about, I'm going to need another wire. So here I've got a potentiometer. It's just a bog standard 100k potentiometer. I've picked this one because it's one I can stick on the solderless board. So we're going to stick that into there. We're going to pull out the centre is the yellow. We're going to look at 5 volt. We'll go into that pin. If I can get it in. No, can't get it in that point. Let's just move this across. That doesn't like that either. Chinese cheap stuff. That's what's going on here. Have I bent them pins? Let's try on this side. That seems better. 5 volt into that end pin. We're going to have that's going to come out to there, and then a ground to here. So let's just disconnect this. Okay, so we're going to have analog in, and it's telling us in the code to put the centre of the potentiometer into pin 0. We then have the other two going into ground, so that's going to ground, and this one into plus 5 volts, which is that pin there. So that's a circuit. Let's make sure that's in. We'll plug this in and upload the sketch. So we're going to upload that sketch. Uploading, done. So we're done uploading. And oh, I've got the wrong screen on. So what we're doing now is, I'll close that down, is we go into tools and we have serial monitor. I click on that and it's come up COM4. So now these zeros here are reading what's coming out of pin 0. And when I adjust this potentiometer, we see it changes. 313, 314, I'm turning it. Turn it up to full, 1023. So we've got 1024 steps on that potentiometer, and it's reading them. So from 0 to 1023. What you can also do is, if I close that down, you've got to close it down, you go to serial plotter, and it puts it in a nice little graph form. A little bit spiky, but I'm turning the potentiometer up and down now, and it's giving us a little graph of what's going on. So we've got an input there that we can read on the PC. So whatever physically is being inputted is now talking to the PC. So we'll just move that to that side. If we look at the code, it tells you what to do. Analog input on pin 0 and prints the results to the serial monitor. It's telling us graphical representations available on the serial plotter, and attach the centre pin of a potentiometer to pin 0 and the outside pins to 5 and ground, which we've done. So on the setup, void setup as normal, it's saying initialise serial communication at 9600 bits per second. So this is basically allowing us to communicate with the Arduino board, and the function is serial begin at 9600. That's a baud rate, so we can change that as long as in the serial monitor we have that set to the same one. If I set it to 38, there's nothing coming from it at that baud rate. 9600, the board will reset and I'll start getting numbers coming in. And then the loop is read the input, very simple, read the input on analog pin 0. So it's saying integer, I want to put an integer out for the sensor value. So whenever I call sensor value in any more of the code, whenever I call that up, it's going to be the analog read. So analog read's a function which looks at what's happening on a pin which we refer to. So it's basically saying, that line of code is, whatever we're reading off A0, pin 0, I want you to store it as sensor value. And then print out the value you read, which is serial.print or ln, print line, sensor value. So we're reading from that pin, storing it in a variable called sensor value, and then here we're printing it to the serial monitor. Here we've got a delay of 1 millisecond for stability. If I put that delay to 100 milliseconds, let's just upload that code. So I'll put the delay to 100 milliseconds now rather than 1. And when we look at this graph, it seems a lot smoother. We've got a lot smoother, but it's only reading from that analog 0 pin once every 1/10 of a second. So we get rid of a lot of the jitters that it was doing before. So you can smooth that out and change your read time, your time it's reading. This should zoom in now, because it's, once we've uploaded that code again, it's done a massive spike to 8,000 there. So there we go, so we're getting that a little bit better, and we don't get as many of the little jitters we got before when I'm turning that potentiometer. The potentiometer is not too bad, it's pretty spot on. So that's that. A little two or three little examples there of using the digital digital PWM output to change the power that's going into a LED, and then this input, which is look at that, it's very smooth. So from them two examples, one thing to look at is, could we potentially, without getting any more example code, could we potentially combine them two circuits so that the variable resistor will control the LED, but through the Arduino board? So whatever this input is will output to that pin 9 like we did before, to control the brightness of that. Now I know you can control the brightness of an LED without an Arduino board with a potentiometer. We know that. But you can't do that and read the number at the same time on the screen, read what brightness that's at. So next video we'll try and come up with a circuit and a little bit of code, cannibalising parts of both them two programs, to try and get effective read of the brightness of the LED while controlling it from potentiometer. So we're going well over time now. That's Spanker out.